Okay, so where we last left off, we were talking about variables and status. We're going to move on to different status information, stuff that's not in status variables, but rather just status itself. Doing like a show table status, for example, and I will go here. Actually, let me do this so that I can get into. Otherwise, I can't get into the bar lib MySQL. So if we do show tables, you see the tables themselves. If we do show table status, and backslash capital G does things vertically. So we can, again, we can see the version. So we see the name of the table, states. You know, it actually does all 7 rows of all 7 tables that we saw. I'll just go through one. The storage engine is InnoDB. The version is 10. Okay, that's interesting. That means that even though we know that we can, if we copy the whole database over, right, from one machine to another, there's actually table format. So if you have a, say, a MySQL table, that's version 7, it probably won't work without some tweaking, which is check table for upgrade, on a later version that's running on format version 10. These are table format versions. So if you end up doing something like a MySQL dump, an export, logical export, and then re-import, you won't have a problem because it's going to create the table correctly.
This is if you use the actual files as your method of re-importing the data. That would be the caveat.
Right.
There are also something, if you, as a storage engine developer, you'd want to know about it too.
Yep. Because it's obvious that MySQL does actually change the versions. One of the, I want to say recent versions, it's one of the versions that I've upgraded from one version to another in the last year or so, went from InnoDB version 9 to InnoDB version 10. I don't actually know what physically changed, but basically something with the table format changed, and it had to do with when you did a MySQL _upgrade after we upgraded, it actually changed all the files. Whatever it needed to do, it did. Row format is compact. There are a couple of different row formats. There's fixed width, there's dynamic for dynamic width, there's compact. So looking at that, I mean, so why is that information there? There must be a reason, right? Otherwise, there's no reason for MySQL to need to know what that variable of row format is. With fixed width data, you get a lot less fragmentation because MySQL can take a row out, and if it knows that the row is only ever going to be exactly 10 bytes long, when it inserts a row that's exactly 10 bytes long, it can just take the place. So you don't get a lot of holes and fragmentation in the data like you can with dynamic data. So that's one reason that parameter is there, because it's important to know when there's fixed width versus dynamic width. You've got a number of rows, which is approximate, as is the average row length, data row length, the index length. Excuse me, the data free this is actually something interesting. Only InnoDB actually handles this data free. It's all 0 right now. It's 0 for tables that actually don't handle it at all, which is a little off. It probably should be null, because data free equals 0 is kind of scary. Oh, there's no more data free. But it's really only an InnoDB parameter. This is actually something that all of the manuals and stuff say, oh, it's the amount of data free. And I actually ended up having to ask someone who actually writes storage engines and said, what is this and why is it 0 for everything except for a couple of my InnoDB tables? And he said, oh, it's just not handled by other storage engines. So again, it's something useful to know because you don't want to go and freak out that your MySQL tables all have data free equals 0 when your disk has plenty of space. It's an InnoDB thing to see if there's more room in the InnoDB table space. In this case, there isn't any more room in the InnoDB table space, but it's auto-extend, so I don't really care. InnoDB file per table, by default, auto-extends the data in index space by itself. You don't even have to have a parameter for that. So it's irrelevant to have this data free because it's just going to keep taking the space. Auto-increment is null, create time, update time, check time, collation, checksum. The checksum is actually interesting. Anyone who read the abstract might know this. I think, do I go into that later?
Yes, you do.
I go into that later.
I'm pretty certain you do, yeah.
Yeah, no, I remember writing a slide on it, but Yeah, I think I go into later when we look at the tables information schema.
Wow, we got a lot of slides.
Yeah, we do. That's good. Oh, that's slide number 50, I see.
Yeah, you actually, we sat down and went over that.
Yeah, I remember that.
I'll explain that.
So let's just do it now since we're here.
Yeah.
So CHECKSUM is my ISOM only. Now, I saw this CHECKSUM thing, and I was like, okay, cool. And I look, and it's 0 for almost all my tables, except for a few of my, no, it was 0 for all my tables. And I was like, well, that's weird. So now CHECKSUM table, by the way, if you don't know. So if I do CHECKSUM table states, gives me a checksum, gives me a number that's, you know, some kind of checksum of, do you know what it uses, or these MD5 or something? It does a checksum of the table. This is very handy. I don't know how many people here have tried to figure out if the data in your master and slave is the same by doing a row count. Okay. Now, obviously, that's not indicative of if it's the same, but if the row count is different, you know the data is definitely different. Same thing with the checksum. Mostly, I mean, if the checksum is equal, it's possible. It's not likely, but it's possible you have different data and the checksum is the same. However, most likely, I mean, definitely more likely than row count, that if the checksum is the same, you probably have the same data. But again, if the checksum is different, you definitely have different data.
And you know, you need to delve into it a little bit deeper and see what kind of unfortunateness you're experiencing. Yes?
One thing people do need to keep in mind is that sometimes the slave can be a half a second or one transaction behind. From even when you like open up a cluster SSH when you execute at the same time, sometimes the master can be one transaction ahead of the slave. And
Okay.
checksum will be different then.
Yeah.
So let's say I do this on the master. Create table, table check, and then we say, you know, machine varchar 10, and then checksum. What's checksum? If I knew what it was, I would know if it's an int or big int. But
you know what we could do is we could do a big int 20 unsigned.
yeah, big int. I'll do a big int unsigned. It's probably like an MD5 or something. It probably could be fit in an int, but I don't want to take that chance. So I'll do a big int, and you know, it doesn't really matter what engine I use, so I'll just use whatever the default is. And so now let's say I do insert into table check. Actually, let me do this. Select at server underscore ID. That's one. Now, if I had a slave, the server IDs have to be different. So what I would do is I would insert into table check machine comma checksum, and I would say values at server. Can I do this? And then can I do this? Can I do like checksum table?
Yeah, you can actually.
Really?
You know, they're variables.
No, checksum table. I would have to do a command. I'm saying the command checksum table. I don't think I can put it in here.
Oh, yeah.
But I could do like,
You could,
you know, select.
into, yeah.
Yeah.
Or set at.
Yeah, set, you know, add foo equal to checksum table. Or actually what you can do is you can update, anyway, you would also have the table name in here. And basically what you could do is on the master, you say insert into it the checksum and my server ID, and that will replicate to the slave. So you say, okay, now show me the table on the master and the table on the slave and where they're the same checksum. And then you don't have that problem with the what if the slave is a second behind, because when it replicated, it was exactly at the same transactional moment that it happened. So that's actually something it's really useful for. Now the thing is, checksumming a very large table takes a very long time. It has to do a checksum. It's not something that, you know, is done on the fly. However, in MyISOM, you actually have a checksum option to the table itself. So if I do something like, I'm going to alter the table states back, engine equals MyISOM, and then I'm going to alter, let's do like a show table status like states, and you'll see checksum is null. And so if I alter table states, checksum equals 1, and I look at the table status, I now have a number there, which is the same number as checksum table states. Okay? Now, the interesting thing was, before I had to actually figure out what this was, because I talked to the same person that I asked the other question who wrote the storage engine, he said, oh, I don't know what checksum is. So I'm like, oh, great, now well, it takes a, so my question is, how does it take a checksum? Maybe if I did checksum table and then looked at the information schema, maybe it's once it does it, it puts it in there. No, nothing. So I finally figured it out, and I did an insert into, states, what do we have, ID, name, and then we do values, 10, Massachusetts, which is where I'm from. Unknown column ID. Okay. I think it was state ID and state name. There we go. And so now if we look at the table status, we see the checksum is here and is changed, but in fact it's the same thing. So MySQL, which does the statistics like row count and whatever, that's all updated, it updates the checksum, but only if you say checksum equals 1. Now before you ask me, well, how much overhead does that take? Because you're saying, well, how much overhead does that take to have this rolling checksum? The answer is I don't know. We've put it very successfully in production without really any noticeable difference. And when I say without really any noticeable difference, I mean without any noticeable difference. But we didn't do a lot of benchmarking or whatever to see. It's just there's actually no noticeable difference. So for me, I would say this should be like default on for all my ISM tables, because it's just so useful to have a checksum. I'm just kind of like, why aren't they just, and there's no parameter to say, whenever I create a MySQL table, always make a checksum on. So,
I'm going into, I want to know this so that I can tell these people.
Patrick's actually going into the include file. See, this is the difference between me and Patrick. Patrick actually looks in the source code. I don't look in the source. I don't read source code. So it's not that it's more like I'm just a snob and I don't like to get my hands dirty. And that's why I did this presentation, because really, I mean, looking at this, it took a long time to figure it out, but this is like the coolest option ever. Yes.
Is there a way, say, immediately after you run that insert or alter or whatever, to capture the check, to just query the checksum and insert that into another checksum table that you created?
Okay, so the question is there a way right after I insert the data to capture the checksum right away and say insert it into another table? Oh, there is. Remember I said I can't do like a function in the thing? But I wasn't even thinking, because what I can do is select checksum from information schema dot tables, where table ID, table schema equals test, that's the database, and table name equals states. So if I do, I can do like insert into, I don't remember what even my table was before, show tables, show create table, table check, except I have to spell it right. So insert into table check, excuse me, yes, I want machine, comma, checksum, and then I want select machine, so it's going to be at server ID, comma, checksum. So there we go. So that's actually how you would do it. And does that answer your question? How do you get, you were looking just, and that's exactly why using the information schema, even though I have to say this whole long query, or rather this whole long query to just get the checksum, it's way cool. It's really good and really useful as a DBA to do that, as opposed to having to write some kind of, maybe a Perl script to look through show table status, and then, awk for checksum, and then get the stuff after the colon and get the number. It's a pain. So having, even though it's in the show tables, having in the checksum is very useful. And of course, as we saw, this is the way that you would actually insert it into a table, and then again, you'd replicate it, and then you'd say, okay, is the checksum of, table states on 1 and 2, 2 being my slave server ID, are they the same? So, pretty cool.
You can also,
Go ahead.
You could add, have it a trigger on both the slave and the master to take care of that for you.
Right. Well, yeah, you could have a trigger on the slave and the master to take care of that for you. Triggers and replication. Do triggers replicate if
the triggers, the action of
the action. So you don't need a trigger on both the master and slave, just the master.
No, not the trigger action is not replicated. Only the query that causes the trigger to run. So you do need it on both.
Oh, okay.
ends. Yeah.
Sweet. I always forget that, and I always look at the manual
I
because
gotta scratch my head a little
I
bit.
know it's important. So show table status is useful, and as we saw, you can get the information in information schema.tables. There's also show master status, which is somewhat of a misnomer, because what it does is it shows where in the, it's really show binary log status. It shows where in the binary log you are now. So again, I'm not inserting anything. The binary log is the change log. I haven't updated anything, so even if I do this, there'll be a new position in the binary log because I've done a write. So what I'm going to do first is I'm going to do a select, so you see that it doesn't change with writes. Okay, so let me do that. So that's in the buffer, and then select. So I'm going to do a select, except I'm going to actually, there we go. And then show master status, it's still 406.855, which is exactly where it was before. If I do an insert, it's now 407.069. So the position is actually advanced. And that's pretty useful. The bin log do DB and bin log ignore DB is have you actually put those parameters in the binary log. You could say never bin log, never write when this database gets a write, or never write when this table gets a write. The database itself is based on what database you're in when you write the command. So if I never want to do binary log the MySQL database, because I say, okay, it's a system database and it's, maybe the users or something are different on one schema, and I do use MySQL, and then I do an insert into test.tablecheck, that will replicate because it technically was in the MySQL database. Even though it affected a table that wasn't in the MySQL, it didn't even do anything in the MySQL database because I was in it. That's actually what binlog do DB and binlog ignore DB run off of. So it's actually better to use the table level ones. And I actually am not in favor of saying don't log this change. I like to log changes and then filter out what I don't want later, because otherwise you could lose the fact that something was done. Especially if you're auditing, you don't want to say, oh, never write down what happens to this database because you might need to know later.
Do you prefer the wildcard ones?
When they work, yeah. I mean, I prefer I actually prefer doing it on the slave itself. If you really want something on the master to not be on the slave, I prefer to have the slave say replicate ignore DB.
No, what I mean is that on the slave you have the ignore DB, but you also have ignore wildcard table or whatever. I don't know if you use those.
If I have to, I do. I try not to. Oh, I don't have a slave here. Do you have a slave?
Yeah, I do. I actually have a running slave. So tell me whenever you... Okay. I'll go MySQL. Yeah.
You can make it bigger.
Can you switch screens?
We will.
Okay.
Can you switch screens?
By the time at the end of this presentation, I'll have that whole switch thing down. Dash H 27.0.0.1 P 7.
Password 9.
This will be fun. Oh, there is no password.
What is it?
Show slave status, make sure it's running.
Yep, okay, then make it bigger.
Okay. Bigger. So it's plus.
Okay, now scroll up a little bit and then highlight the...
Shrink this window a little bit.
Just, yeah.
I'll make this. So is this big enough for all of you?
Okay.
So what do you want to see?
Scroll up. We want to see the replicate. Keep going, keep going. Okay, so...
See, I'm using the replicate while
They can't see when you point it there.
Oh, yeah, that's right.
Use the
Yeah.
use the pointer and highlight.
Yeah.
Although you guys can all see that.
I use this on the client. I like these because these give me a lot of granular control. Sometimes I'll have, for instance, a bunch of tables that are like named, but then I'll have one table out of those that I don't want replicated. And so I'll use the wildcards to do that. But, it's all a matter of preference.
And again, the DB ones, replicate, do DB, and replicate, ignore DB, are just what database you were in at the time. Actually, let's take a look at your binary logs. We didn't actually go through that when we talked about files.
Okay, we can do that.
So, since we're there, no, go to the other window that was big.
Okay. Oh, you want to? I'll go ahead and exit out of here.
Sure.
I have on this box. Last year, I gave a talk on replication for dummies.
None of you guys were there because you're all smart.
No, I was the only dummy. I have a multiple instances on here. So I have like 3 of them. I have 2 of them running right now. Anyhow, we have in here.
Let's do MySQL bin
I'll
log.
start in
Yeah, do an LSH over there. Are they big? So do like a MySQL bin log of this one. So the binary logs are in a binary format, and you have to do MySQL bin log to read them. And actually, let me. So I was talking before. See this set timestamp? Everybody sees that? That's highlighted now. That's actually how it knows what time to actually put when you have a current timestamp or a now. That actually doesn't work if you use sysdate. So, although there's actually a parameter in MySQL that you can set called sysdate is now. So if you are like we ended up finding a client that was using sysdate and was like, why is everything in our East Coast data center have 3 hours more than everything in our West Coast data center? And it's because they were replicating and using sysdate, and so we fixed that. But you can see, here's the insert statements that it does. It notes the position. This is actually the position in the log file, so it's at 2404. So let's say you were starting replication, you would actually want to know that position. This is the date, and these pounds are comments. The dash is the standard comment for SQL, but so is the pound. So this happened on April 20th, 2009, at 12:30 local time. Server ID was 1. The end log position is 2536. So the start position is 2404. The end position is 2536. The type was a query. Thread ID is 1, and exec time was 0. It didn't take any time to do. And so that's it.
One of the things that this is really, really useful. Just last week at work, we had a slave, our only slave server. When he restarted it, all the InnoDB files were corrupted. He couldn't get them to repair. It kept restarting. And I said, well, one way we can repair this is to use the backups. What time did you do the backups? And he told me 3 a.m. in the morning. I said, well, this is how we can repair this. We can load we can stop the slave, reset everything on the slave, load the dump, and then get the position from the binary log on the master of when that dump was done, 3 a.m. We can start with that position. And we actually set ignore all errors, because there might be some slop in there where you might get a couple queries that were already run. But we were able to make the long story short, we were able to restore everything knowing that position and using replication to actually bring the database back to the stage where it was before everything crashed.
Yep. Yes.
So when you take the backup,
Can you be loud? I can't hear you at all. I'm sorry.
So when you take a backup, you can actually provide ask MySQL to provide the information about the replication position.
Yeah.
The question was when you do a MySQL backup, can you get information about the where the position is in the binary logs? The answer is yes, and where the slave is in the master binary logs. The answer is yes. If you're doing like a cold backup, then like a cold backup where you stop the server and copy the files, there's a file called master.info.
Right, yeah, master info.
Which is there any secure? Because it shows passwords, so I don't want to show if there's going to be. Okay.
Yeah, this is all demo.
So here's the master.info file. This 15, I'm not really sure what it is. I think it's a kind of a timeout thing or something. That's the master binary log that's on bin.006. 106 is the position. That's the host. Here's the username. Here's the password. As Patrick said, it wasn't secure. 3307 is the port, and then 60 and 0 again are not big deals. But if I do this, is it password root -p root? And I do show master status here. It should be show slave status. I'm sorry. It should say it's in position 106 of binary log, whatever it was.
The gotcha there that I got to point out.
Yeah, exec master log.
As soon as you start the dump, before you start the dump, stop your slave.
That's what a cold backup is.
Oh,
Stop
cold,
the
I see what
slave.
you're saying,
So this
okay.
is a cold backup. Stop the slave, whatever. If you are doing it while the database is still running, again, if you're using like a hot copy, you can copy the master.info file. One thing I would say though is that the hot copy will lock the tables, so that's okay as long as you're locking all of the tables. MySQL hot copy will only lock one database at a time. So if you really want a consistent snapshot of more than one data, again, if you're doing an LVM snapshot, it will take a snapshot of the master.info file. But most people, what they'll do is they'll do a slave stop. They'll do slave stop like this. and then do a either copy the master.info or do a show slave status, and they'll say, okay, here's the exact master log position. That's, sorry about that. That's where I am. I keep doing that. That's how do I just want to scroll up to there.
Yeah, I'll do the scrolling.
Here, master log file. So there's master log file, read master log pause. So here's something interesting that you actually may or may not have known. Replication is actually a two-threaded process. It's on the slave, which you may know because you do all the functions on the slave, right? You change master to, you set all the parameters, and you say slave stops, slave starts on the slave. So it's a pull mechanism from the slave goes to the master and gets stuff. It's a pull mechanism. Obviously, you can do it from remote things. Connect retry is 60. I think we saw that at the bottom of the file there. Master log file. You have a read master log position and an exec master log position. And in fact, replication is actually a two-threaded process. If you do a show process list, you'll see that, we stop the slave. So slave start. And you'll see that you have this replication user, which it's waiting for the binary log on the master to be updated. This is the I/O thread. It's file I/O. It's getting the bin log information from the master and saving it to the relay log on the slave. That's one thread. There's another thread called the SQL thread, which is this one. Note it's running as the system user, not as root, as the system user. So this is an internal thing. It's actually waiting for an event. So now what happens is the I/O thread will go and get information from the master. And regardless of how far behind or ahead, the slave can't be ahead, but regardless of how far the slave is lagging behind, the I/O thread will pull, as long as it can, there's no network problems, will pull the information from the master and save it in the relay log. And the way that MySQL actually does that seconds behind master is it takes the information from the relay log and says, okay, what's the latest transaction I know about in the relay log, the last one, and what am I on now? And what was the timestamp of that one, and what's the timestamp now? So if there was a very long transaction an hour ago, and you're still working on that one, and there's been nothing since then, it's going to say it's an hour behind, because the transaction is an hour behind. Now, if you've ever started a slave and have it be really far away, then did you want your screen on, or? I
wanted to show them an illustration of the slave and the master.
Okay. Okay, I'll let you do that, and I'll keep talking. If you start a slave and there's a lot of information to get from the relay, let's say it's a day behind, the I/O thread is grabbing the information. And so you might say, oh, it's only an hour behind. How can it be an hour behind when I know it's a day behind? Well, it's because it hasn't actually gotten all that information from the relay logs yet. So sometimes second behind master can be actually pretty misleading. If there's like a network issue and the relay logs can't come, if the relay logs can't come up to date, then it will think it's very far in the past, and you'll have a seconds behind master of 0 because it thinks it's all caught up, because the I/O thread, right, the SQL thread has executed everything it knows about, and goes, okay, I'm ready for more, I've executed everything, and the I/O thread goes, I don't have anything more for you, but maybe it's because it can't connect, or maybe it's because it's frantically getting more, but it's not keeping up. So that's one of the things you might hear people go, oh, seconds behind master isn't really accurate. And it is usually, but it can be a bit misleading. So if you look at show slave status, the way actually we end up, keep doing that.
Sorry.
No, it's not your fault, it's mine. The way that we actually do that is we look at the master log file, and we look at the positions, we look at the exec positions, and one thing we do, there we go, is we make sure, this is for the SQL thread, so if the SQL thread is running, this should be going pretty well, but if you look at the read master log position, that should be up to date. If it's not up to date, your I/O thread is lagging. So really what we do is we end up subtracting the exec master log position from the read master log position. And what you really want to do is you want to connect to the master, which is what we do. We connect to the master. We say, what binary log are you on? Like show master status. And then we compare it to the binary log that the slave is on. Because if the slave doesn't even know about the binary logs from the master, then it might think it's up to date when it's really not. So anyway, this is, it's kind of interesting that you can just look at replication and see, hey, there's 2 threads there. There's something that's doing a read and something that's doing an exec down here. I don't know why they spaced them so far apart, but there you go.
I have this Perl script I use for backups, and what it does is it stops the slave, and it waits for both of those values to match, meaning that everything's caught up, and then it does the dump. It creates a file that has the slave in the master position that says change master to. So what I end up with is this nice dump and a file that I can run and create a fully working slave anywhere I want. And there's even a patch that I did with MySQL dump that does that very thing that the Perl script does, but it's in MySQL 6.0. But I can make that script available to anybody. It's a pretty useful script.
Great.
Let's see.
I was going to talk about maybe some profiling.
Okay.
Are there any questions about binary logs? Yes?
I just have a quick comment about binary logs. That's pretty handy.
Uh-huh.
You can replay them in a process and then count the number of executions against various tables and kind of build your own counter mechanism that shows you how busy all of your tables are against our companies and deletes.
So the comment is, like the status variables only show you, say, how many questions have been done, how many selects have been done. They don't show you, say, how many tables have been done. And the suggestion is you can actually take the binary log and replay it. Or is it like looking through it with a script?
Yeah, just use MySQL bin log, dump it out in the text.
And then you use like a Perl script or something to parse it. So you don't really replay it in the MySQL. You basically do a MySQL bin log and read the file, and then pipe that into something that can look at which databases and which tables it does. So you can see, oh, how many inserts were on this table, how many updates were on this table.
That's incredibly useful. It's very easy to do. You can just have a Perl script that sucks it all in and have a little TCP server on it, and then you can connect like a Qcache.
So can we like download your script that does that and those Qcache templates? You're going to make those online like before the end of the session, or you'll put your best people? I mean, if it's something that could be shared, that would be great. If it's company proprietary, I understand, but is it something that could be shared or no? You'd have to ask. Okay, that's your homework. We're actually all going to get homework later. That's your homework. I don't have your name, so I can't really like embarrass you sometime other. Like I can't go blog post about it in a week going, this guy didn't do his homework, but that would be awesome. No, but you can. Okay, you know him? Okay, great. Do you know, who here has heard of Baron Schwartz? Who here has heard of MatKit? He makes MatKit, MK Query Profiler, MK Table Checksum. So one of the things that Baron has is a set of Qcache templates. And I am sure that Baron would love to put this in his, package of Qcache templates. So if you want a little fame to go along with your homework, that could be it.
That'd be a really cool graph for cacti.
Yeah, that's what he was saying, is that it could be,
I'm reiterating.
Cacti. Can you see if that works in your thing? I'd like to show you, does anyone use show profile and show profiles? Okay. Because I want to show that, but I'm running like 5.122 or something on this
my
laptop.
EC2 instance here with Maria. Let's see. Where are we? There we are.
Okay. Set profiling equal to 1. Sweet. Okay. Now, I guess I'll draw. You guys can see this all, yes? Or should I make it bigger? Yes or make it bigger? That's fine. Great. Says the person in the front row. So if we do show profiles, there's nothing really there. But let's say we do select sleep of 10. It's going to sleep for a little bit. Let's also say we do select star from states, except it's not really going to be there. So that'll be an error. We'll do a show tables. Oh, no database selected. Okay. Let's do a show databases. Use test. Can I do show tables? What confidential information I'm going to show here? Select star from T1. Okay, now if I do like a show profiles, this actually has the last 8 queries. It'll actually go up to the last, I think, 15 queries. And this is my sleep 10. Here's my select star from states, and you can see, okay, they didn't really take, obviously, I heard a wow, yeah. It gets better. That's the cool part. That this ain't the half of it. Actually, this is half of it. So it's actually really cool. You can see my sleep 10 took like 10.02, whatever, whatever. Interesting that show databases took a really long time. And there's only 3 databases. And why did it do that? Well, it had to go to the directory basically and read all of the directories in the data directory, because it doesn't actually, it actually does that. It's not something that's saved in a table somewhere. Show tables again took, a little bit of time. It took a lot less time the second time, so maybe it cached it or something, who knows. And then select star from T1 took 0.03 seconds, which drives what we saw here. So if we do, let's see, okay, I just want to get the syntax. Show profile for, so that was show profiles, show them all. So if we do show profile for 1, which would be query ID number 1, for query 1, sorry, for query 1, this would be the cool part. So it took 0.018 seconds to start. It checked permissions to see if I had permissions to do what I needed to do, if I only need to access a table. Opening tables, init, optimizing, executing, user sleep, not quite 10 seconds, but close enough. And then it had to end, query end, for reading items, logging slow query. So how much overhead did slow query log take? A little bit of time. I don't know why it's there twice, but there you go, and cleaning up. This is amazingly useful. This is actually a community contributed patch. Jeremy Cole contributed this a while ago, and it got into 5.1. Anybody using Enterprise 5.0 actually had it for a while before it wasn't in 5.0 at all, community, but it was in Enterprise 5.0. This is fabulous for doing stuff. So we had, this was query 8, was the, well, if I do show profiles.
This really shows you how MySQL works without having to look at the source code.
Sheeri.
Yes.
Add comma source. Profile comma source.
Add show profile comma source.
Yeah.
I learn something new every day. Do you have like show source? Does show source for query 8 work? Yeah, that's not in any of the documentation I had, but it would have been cool. Let me show the select. It might be a different version.
Show profile space source.
Show profile space source for query 8. Aha!
Wow.
Line of code and the source code query.
Yeah, but the whole point of this is not to have to do the source code. But but it actually is pretty cool.
Oh, but you can brag about, I know what source file that's in.
You could be like, man, lock.cc is just taking up all my time. Let's just delete that file. No. No, it's already compiled in, so you can't. But that is actually pretty neat. Stop getting ideas. We're in the middle of a presentation.
We could get this for 5.0?
It's in like one of the enterprise versions of 5.0. But really, the upgrade to 5.1 is not that big of a deal. What about CHECKSUM? What about it?
Tell you what file CHECKSUM is using, so I can.
Oh yeah, so like if I do CHECKSUM table T1, okay, and then I think that would be query number 10. But let me see the show profiles. That's query number 12. So we do
query number 12.
Show profile source for query 12. Actually, let me do it this way. \G. So the actual query itself, what exactly did you want to look? Starting?
I wanted to know where the actual checksumming, what.
System
I think I know
logs,
what it
table
is.
log, query end, freeing items. I guess it would be, well, this is MySQL execute command.
Okay, so it's at a lower level that it's not showing. This is showing you the higher level.
Right, it doesn't tell you the function that checksum is. But
Yeah.
At any rate, so if you really want to know where your things are going, freeing items, it's pretty useful. If you're having memory issues, again, logging slow query, how much overhead does that slow query take? Cleaning up, it'd be useful to know what cleaning up actually did, but okay. It's interesting that it also gives you the source function too. So for instance, freeing items is in the source function MySQL parse, which is kind of interesting to me. Like, what is it freeing? Did maybe the parser, right, put some things into some variables to use later, and now it's cleaning up those variables? Again, I actually have no idea. But table lock, obviously, table locks are actually logged in the slow query log. But system lock, okay, it's actually in the same source function in a different line of code. But yeah, so if you do want to jump from this presentation to reading the source code, now you can.
It can help you identify problems too. If you had for instance, some disk issues, and you saw that lock tables was, a file lock or something like that was taking a long time, it could point to something. A couple of weeks ago, they had a problem at work. They said, for some reason, everything's really slow when we do backups and copy all this data from one server to another. I said, yeah, that's because the disk, you're copying data
File I/O.
on the same disk that the data files are on. And if you look at it closer, you'll see that that's the case.
Next, is there anybody else want to talk about anything about show profile, show profiles? So I'm just going to go back and use this on their slow query. Yeah, okay. What, only 3 people?
That guy likes to ask questions.
The other people are like, I'm a developer, I don't have access to the log. So I'm sure everyone that could use it would, but it is immensely useful. There is actually a page in the manual that explains how to use it. You saw you actually have to turn profiling on. So I don't know how much overhead profiling has. Yeah, it's a show profiles syntax. Let me go to 5.1, and it won't have this warning about MySQL Enterprise users. Or maybe it wasn't in 5.1, I don't know. At any rate, show profile, you can see, show profile source, you can see show profile memory. I actually did know about that, believe it or not.
Memory's not implemented.
Memory's only what?
It's not implemented.
Oh.
Featureware.
It's featureware. Yeah, that's I hate it when they do that. Yeah, I think a bunch of these things aren't actually. Let's see if show profile block I/O will. I actually remember when I did this section of the book that says block I/O. Oh yeah, so block ops in, block ops out, so you can see how many blocks something is using. What about query 8? I guess we haven't been. I guess if everything is in the all the memory not on disk, maybe it's not using any. But anyway, so it's pretty useful. The size, as I said, it shows you the last 15 queries. There's actually a session variable, not global session, called profiling history size. This all kind of points to something. Oh, can you switch it back? I'm highlighting it on the screen here. There you go. Profiling history size, which has a default value of 15, maximum value of 100. If you set it to 0, you disable profiling. So it kind of points to the fact that you don't necessarily want this running all the time on a production system. However, I think because you could just kind of turn it on, I think it's immensely useful. And again, it's a session variable, so you can't turn it on and look at somebody else's session. But it would be very useful to put in a debug kind of a mode. So let's go to some EnoDB status. Show engine EnoDB status. Why don't we just switch it here and just use this?
I think I have InnoDB on this box.
More. Oh, switch back now. So one thing I'm doing is I'm going to be setting the pager here. It's \P. I'm setting the pager to more. You can set it to less. You can set it to grep for something. There's a few different commands you can set it to. Not on Windows, only on non-Windows. So now if I do if I do the show profile like that, well, if I do it like this, if it goes more than a page, you can see I have the more down here, where I have to hit space to do that. So if I do now show engine EnoDB status, there's a whole ton of information about EnoDB that shows up here. Now, unfortunately, this information is kind of in a running log kind of a way. It's not actually stored in a table at all. It would be very useful for it to be stored in a table, but it's not. So, here we go. There's one row return. We've got here's the EnoDB monitor output. You get the number of semaphore. You get the semaphore, not the number, but you get the semaphores, wait array, mutex. If you know what these things are, you know that it's talking about transactions and locking and mutual exclusion to who has the lock on this, who has the lock on that. It talks about deadlocks later. So again, if you knew nothing about EnoDB, and you looked at this show engine EnoDB status, you'd be like, aha, it's transactional, right? Here's a transaction. There's a PERD, there's a history length, here's a list of transactions for each current session. This isn't a historical thing, it's a current session. So the current session is running, right now, the only thing running is a show engine InnoDB status, but it's thread ID 7, query ID 52, and it's from root at localhost. File I/O, so a lot of it right here is waiting for an I/O request. If you have something very interesting, so one thing to note, InnoDB page file size defaults to either, I think, 8K or 16K depending on versions. But I actually ran into an issue where I was running Solaris ZFS, and the Solaris ZFS page size was 128K. And I was actually converting a box to InnoDB file per table, so I had exported everything, and then I imported it was like 300 gigs, and I was importing it, so I went to bed, woke up the next morning, and it was still on like the A tables, and I was watching, and it was importing very, very slowly. And we finally figured out that the problem was the page size. So every time InnoDB wrote, a page of data, 16K, the operating system was actually writing 128K of data. So we actually had to change the ZFS page size. But that's something that you can see here. Is it in the middle of what are all these threads? Are they waiting for I/O? Are they in the middle of I/O? What are they doing? And we would have seen, and in fact, the behavior that I saw when I did a show process list, I saw that the slave status, the execution, the SQL thread, would do an insert, and it might take 2 or 3 seconds to do the insert, and then it would sleep for about 60 seconds. And I was like, what's going on here? And it would sleep because it was waiting for the page to finish writing. So that's the kind of thing that you can see here. You can see how's the file I/O going. Here you've got the flushes again. We were talking before about the flushing when you get the dirty pages. If you get more than 85% of dirty pages, it'll flush. Things like that. You've got this insert buffer and adaptive hash index. So it talks about hash searches, things like that. The logs, and this is the redo log.
Yes.
Buffer pool of memory. So here's all how many free buffers are there, how many database pages are, how many modified. That's dirty pages, pending reads, pending writes. So row operations. If there were any deadlocks, they would have shown up in the transactions section. Right, transactions? Yeah, deadlocks, I believe, would have shown up in here.
What would be interesting is to look at this for a really busy site that's got a lot of
problems, yeah. So this is in the notes where you just have, semaphores, transaction information. That's just kind of each heading. So let's move on to the information schema in the last hour or so that we have. There are a lot of tables in the information schema. This is actually all of them. It's about, 27 or something. But they represent a huge amount of information. There's a bunch of them are like character sets and engines. They're actually the metadata about MySQL itself. So if I do something like, and a lot of them have similar show commands. So if I have show engines, it shows me the engine, the support, yes, no, the comment, transactions, XA, and save points. So if I do it in a vertical way, right, the archive engine doesn't have transactions. There's no save points, whereas InnoDB has pretty much everything over here. Is there support for InnoDB in my MySQL? Yes. Here's the comment. It supports this kind of stuff. You can actually make your own storage engines and put whatever you want in that comment. Yep, here. Default engine as of MySQL 3.23 with great performance. Okay. I just like the fact that it has a value judgment in the comment itself. But if you do select star from, well, let me use, the only thing I don't like about the information schema is that you have to type out the word information_schema. So if we do select star from, we actually type star, engines, you get the same thing that you just saw in the table. However, we can decide to select engine support and say comment from engines, right? So we can get rid of, we don't care about XA, or maybe we just want engine support, or maybe I want engine support and transactions. So what's the transactional database? So one of the greatest things about having it in the information schema is that it's a lot easier to query and get exactly what you want. Did you want to?
Yeah, I was going to show them on here. There are a bunch of other different storage engines. We have Federated, which is the default Federated. We have the merge MyISAM. If we keep going down, we'll see some other ones that you might not have seen before.
Federated X?
Federated X, which is one that I've worked on. It's a pluggable one. You can compile it outside of MySQL and install it, and then it's...
Well, before we tell you about Federated X, everybody over 21 here? Just kidding. Okay, sorry. Why did you call it Federated X?
Because Brian thought it was a good idea. No, because I couldn't use the actual Federated name. But that's,
Okay.
I'm going to change that pretty soon. I'm just going to make it Federated.
You know, we were talking earlier about how, Oracle just bought MySQL, so we could call it Moracle. Which just seems kind of wrong, but anyway. It's better than my Oracle, so.
I should put a better in there.
You should be like,
Yeah.
Federated X, the best federated storage engine ever.
And this one has actual, it does have the transactions.
It does have transactions, which is kind of interesting considering it's a federated. What if the federated table itself doesn't have...
It
What if
does
you're-
depend on which storage engine you're using, but what the remote table is. But the federated part of it supports running transactions.
If the remote table supports transactions, you can actually still do it. Whereas the other one, the other federated one didn't, right? So if I do select star from engines, where engine equal engine like federated %, colon, well, fine. I have to write information schema.
I wish we could do I_s.
I so do too. Engines. There we go. So you've got transactions. It actually says null, which is kind of weird
I was
because
very
it either
explicit.
does or it doesn't. There's transactions null. Well, that would probably mean no. There's really no undefined. It either does or it don't. So anyway, transactions, yes. So basically, it's not supported in Federated. It is supported in Federated X. So let's see. What other engines did you have? Maria in here? Yeah,
Yeah,
here's
Maria.
you're playing with PBXU. Ooh.
No, the Maria tree,
Oh, the Maria tree has that.
plug, comes with a lot of stuff running out of the box, which is quite nice. Well, of course, I did the max compile. The max compile compiles everything, but their idea is to get everything. So you can see here, another transactional engine. XA, I guess it doesn't have that. I haven't used PBXC, but I've heard good things about it.
Apparently, it's a high-performance engine, so that's good.
Yeah, I think it has a lot to do with blob storage.
It does. It has blob and blob streaming, and it does it very efficiently.
And those guys will be, I'm sure, giving one or more talks on it. And then, of course, you see Maria here, and I mentioned that it has the MyISAM heritage, as far as the speed and everything.
Yep. So another thing let me use information schema, since I don't think I was there already. So if we do select star from character sets, which was another table that we saw, you have character set name, default collate name, description, max length, and there's 36 different ones that you have there. Collations are the sort order, and collation depends on the database, on the character set itself. So again, what can we learn from metadata from this? Well, that means that it's possible to change, right? Why is there support in it? Well, because you could have your database, and MySQL was a little nuts with it, where there's like 7 different, show global variables like %car %, and you have character set client, connection, all this stuff. You have 8 different character sets that you can choose from, that you can set. So playing with character sets is kind of a weird thing. It would be better if it was just all UTF-8.
Yeah, it depends what kind of data you're storing. The previous company I worked at Grazer, we did all this stuff with RSS and XML feeds. We stored them in a database so we could create a big search engine full of feeds. And we were constantly getting bitten with character sets, so we went to UTF-8, and that made life a lot better.
Can you switch back?
Yes, I most certainly can.
All right, so besides the information schema tables like character sets and engines that give you metadata about MySQL, the whole server itself, there's a whole bunch of database objects. So schemata is just databases. So show databases and select star from schemata are pretty much the same thing. Tables, we went through that a little bit. You know, I showed you that show tables table itself. I think there's a little more on it. Views, partitions, files goes along with partitions. So this is from a 5.1, MySQL 5.1 that actually has partitioning on the table level. You can set up different partitions. I'm sure there's like 17 different talks about partitioning in 5.1. It's good, and it also has some limitations, but I'm excited about it. So, you know, I know that it has some limitations, but it's still pretty good. Files goes along with partitions. Columns is the columns in a table. Routines, stored procedures, and stored functions. Events are events. That's a new thing in MySQL 5.1. It kind of replaces all those little cron scripts you have to, you know, do something every 5 minutes in SQL. The events will do that for you. And the best thing is it's in the database. So when you back it up, you back up the event too.
Oh, how do you set an event?
Create event. Yeah, you can create an event.
Ooh.
Any
SQL statement, that's it?
Any SQL statement, yep.
Yeah.
Even calling stored procedures and things like that. And if there's time at the end, I can show you how to do that, or afterwards. There's also a MySQL manual page that probably has a little event or whatever. It's actually really neat. I mean, if you know, when I worked at like a dating site, and they had something like a number of people online at a time. Right now was 50,000 or whatever it was. And what they ended up having to do was, at first, they just said, okay, do a count star of the sessions table. But that was taking too long on every single page. Every time you go to the any web page, it said this many people online. So then what they decided to do was to have a table that says how many people are online, and every 5 minutes they had a cron job that says insert into table, select count star from sessions, which worked. But that was a cron script. So if they ever had like a new web server that they added, or if they ever had to have a disaster recovery, for instance, you have to know that that cron script is part of it. So using an event is actually better. I think it's better because it's just a simple SQL thing, and when you back up the database, the event is right there. So the actions that you do about the data are with the data, and I think that's very important. So it also has information about triggers and information about plugins. So these are the database objects. There's a lot more tables, but we wanted to kind of break them up into groups. So the data objects, instead of the show databases, you could do select schema name from schemata. Not really a huge thing. One of the biggest things, I can, if you bring up the slide, I can read from your slide and do it on this one.
Okay.
So either way. So we've got, show databases gives you the list of databases. I'll just do a select star from schemata, and that gives you the catalog name, which is actually, catalog name is just it's something in the standard, but it's not implemented, so it's just always null. You've got the schema name, which is the database name, the default character set, the default collation, and SQL path, which right now is just null for everything. But it's kind of neat because it makes you think, oh, maybe in the future we'd be able to, set different paths for different databases or something. We have this show process list, which we'll go into a lot more detail in a little bit. Process list, which has, ID, user, host, database, command, time, state, and info. Who has used show process list? Okay, who's used it to try to find like the slowest queries? Okay, who hates that? Okay, so here, now that it's in the information key schema, right, you can do select, let's say, ID, user, host, command, we don't really care about the database, let's say, command, time, and info from process list. We could say where time is greater than 300. And of course, it won't give me anything because there's nothing running more than 300 seconds. But you don't have to get all of that information. You can just get what you need, and it's very, 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 very useful. So that's that.
This allows you to build actual tools that report all this information.
Definitely.
And that's in 5.1 too, right?
That is in 5.1, correct. Here we go. So process list. So we have the user, the host, the DB, the command, the info. Command here is query. there are tons of different, actually not tons, there's maybe about a couple dozen commands. There's actually a whole bunch of states. See, the state is actually null. There's a whole bunch of states that actually help you figure out a bunch of stuff. So some of the commands, let's go back to me.
Okay.
So some of the commands you've probably seen: query, we just saw sleep. That's when a query isn't doing anything. Statistics is when it's dealing with gathering data or whatever. Kill is when you kill the query. Field list, when you first when you first log into a database. If you actually, I guess go back.
You can show a kill by doing a sleep. Kill the sleep.
Well, no, because it kills it right away, so you won't see.
Oh, yeah.
You would have to actually grab it at that second to see the kill.
You have to write a Perl script that constantly query. And
right. If it takes a long time to kill something because it's an altered table and it's going back or something, you'll see that thing. The field list is when you log in. If you by default on I think it's non-Windows machine, it might be everything. It actually will grab information from the data dictionary to get things to do tab completion. So for instance, I'll exit here, and if I do that, you can, and I do use test, and you see it says reading table information for completion of table and column names. So that's exactly what it's doing. It's getting all the field lists. So if I say select star from S, I tab complete and it went to state. And I've got states, state ID, so states is the table, state name is a field, state ID is a field, states.state ID, states.state name. So that's pretty cool. But it could take, if you have a lot of tables in a database, sometimes it will take, and especially if they're being used, it might take a long time to read that information. If you don't want to read that information, you just use the -A flag for MySQL. And so if I go to use test, it just says database changed. And if I say select star from S and do tab completion, it's actually trying to complete the commands. I could use select, I could use set, I could use show. These are all the things I can,
Cool. That's cool.
Yeah, there's tab help. There's also help, like if I want to do, there's command line help. So if I say help show, it actually gives me a whole bunch of stuff here.
The help is really huge.
It is huge.
When I wrote my book, Monty pointed out that I should really highlight that because everything that's in the MySQL manual you can find with the help commands.
Right. So if I do like help, and it actually gives you the URL, which is also pretty good. So if I do like help profile, help show profile, would that work? Instead of going to the manual? No.
Profiling?
Help what? Help show? Yeah, but then it just gets me to show, but...
Help show profile, or...
Oh, help, yeah, but that's what I just... Well, let's see if help show profiles would work. Oops. Oh, is that an example?
Yeah. Wow.
Yes,
Oh,
there you
wow.
go. Okay.
Did it actually run the code, or?
No, well, I know, it just
looks
gave,
like it did.
It did. That's why I was like, what? What did I do? So yeah, to look up the syntax for show profiles, instead of going to find the manual, I could do it here, which is actually pretty useful, and I should use that more than I did, considering I just like, oh, let me download the manual to my computer if I'm ever offline. Now you don't need that.
So help in itself is kind of metadata.
Yeah.
You could. If you're on a plane and you have no internet connectivity, you don't have to worry about getting connected. Everything you need to know about MySQL is there for you.
Yep, and that's all actually in the help topic table here. I think there's also a help. Yeah, there's a whole, see these help tables? It's all in there. And they actually make the MySQL database quite large actually, which gets us to sizes. Now, size, as we know, matters a lot. In databases, of course, that's what we were all thinking. We were talking about show tables before, show table status, which has a lot of stuff that's in the MySQL, the information schema. But notice that, it has data length, this happens to be 0, and index length is 0. If we go to, we did go to information schema. If we go to select, one thing that's interesting, so again, as with other things, MyISAM has exact data length and index length, where InnoDB has approximate index length and data length. Now, we were looking at data files and index files before. So one thing that you can do is you can actually check out fragmentation, or you can try anyway. No, go back here. No, it's all good. What I wanted was to go to the things here that has the notes on what to do.
I should do that.
So let's say one thing I wanted to do. I just wanted to show you the size of the help database. So if I can do like select data length, index length, table name from tables where table name like quote help percent. So we got help category, help keyword, help relation, help topic. That's kind of annoying, so let's do divide by 1024 as data KB, and index length divided by 1024 as index KB. So we've got about 338K. This is probably where all the information is. Yes?
Here, are these actually, are these exact?
Are these exact? I think so. So this is the MySQL tables are system views, but I believe they're MyISM. So actually what we want is select engine. Yes, they're MyISM, so therefore they are exact.
Okay. And I don't know if you mentioned earlier, but both the row counts and InnoDB, that they are quite approximate.
Yes, correct. Just like just the statistics such as row data and even data length and index length in InnoDB are approximate, and in MyISM they are exact. Similar, and the checksum also is exact in MyISM. There is no checksum in InnoDB, but InnoDB updates the statistics for, MyISM updates the statistics for things like row count and stuff on every update. So it's always exactly accurate. InnoDB does not. You can do an analyze table to redo some of that stuff, and again, it's not exact. It goes and gets a sample and uses that sample. So there's never a guaranteed, like, you might think, well, maybe I could do, maybe when I do analyze table, it does like a count star and it's exact until such time as something changes. No, it just does sampling. So let's do this.
Does he look at the actual data file?
Yeah, so let's do ls-l MySQL help star, and we have a whole bunch of that. Let's do help star MYI, and go back here. So if we look at the index files, right, help category is 3072, which is 3 kilobytes. That's exact. 14336 for help relation and help keyword. That's 14 kilobytes. That's exact. And then help topic is 17 kilobytes, and it's 17408, which I'm sure if I did select 17408 divided by 1024, 17 kilobytes. So let's now look at the data size, MYD, and this. And again, I probably should have just left it here, but if we do select 347064 divided by 1024, we're going to get 338.9297. Now, the interesting thing about this is if you have a table that is a MyISM table where the MYD or the MYI is greater than the information schema, you have a fragmented table. So you know exactly how fragmented it is. It's exactly as fragmented as the file size minus the length in InnoDB. So a lot of times, you want to know, this table has bad performance. Why is that? Maybe it's because, it's just being used a lot and you can't help it, or maybe an optimized table will help. Well, if your table has 14 million records, right, you don't want to make that guess. You don't want to be like, okay, well, we'll take it offline for 2 hours while it doesn't optimize, and then we'll figure it out. This is actually a way you can figure it out, which, again, pretty cool.
You could kind of monitor it, see what your fragmentation is.
Exactly.
Take proactive action.
Proactive action, yeah. So
This will work on InnoDB, right?
this will not work, correct. This question was, this will not work on InnoDB, right? Correct. However, InnoDB is in fact approximate because it does a sample. So what you can do, so here's select table name, data length, index length from tables. InnoDB also puts indexes and data together. So if you have a shared table space, you're not using the InnoDB file per table, you can select the sum of the data length plus the index length for all the InnoDB tables, and then look at your IB data file. Now, again, the information is approximate. You may find that the information schema is actually greater than the size on the file, which is obviously impossible. But again, it's approximate. And I would say, if there's, say, a 10 to 20% difference, like if it's 10 to 20% larger on disk than it is in here, you're probably fragmented. That's probably fragmented. You could say, I think if it's less than 10 or 20%, that could just be the approximation working.
Yeah.
But it's at least a good feel for it. I mean, if you've got, if you've got an InnoDB database that's 100 megabytes or gigabytes, let's say, and your IB data files add up to 200 gigabytes, you're very much fragmented. I mean, you're definitely fragmented. So it's not exact, but it's close. And you could probably, didn't you write something to make something more exact?
At Lycos, we had a need to know how much disk space. We always need to know how much disk space a tripod user is using on disk. Well, now that we've added MySQL, we need to know how much disk they're taking on as far as the database goes, and calculate that in with the disk space on the NFS server. So I wrote these UDFs that just do an LS stat, and it's per schema, because we just want to know per schema. And then each user has their own database prefixed with their user ID.
And are you saying InnoDB file per table?
It can be whatever they choose.
Oh, whatever they choose, okay.
Because they can create their tables any way they want. So I need to be able to look inside the schema and count every file and add it up. And then the MySQL UDF API, I know this isn't a talk about that. It's pretty easy. And I'm trying to talk to them about open sourcing that. I think it's a very useful thing. And it's simple. It just does an LS stat, which is harmless.
Yep. So if you're file per table, you can actually compare table sizes. You don't have to do a sum of everything. You can actually say, okay, what's this table name? But again, it's the sum of the data in the index, because MySQL InnoDB puts them together. So then you have to do a ls-l of star IBD, or somehow get the file size of the .ibd files. And again, these are all in the slides, and I'll show you guys how to download the slides again at the end. There were some people in the middle of the break that I showed how to do it, but I guess not everyone was here. I don't want anyone to get carpal tunnel or a big collective awe when I switched to next slide, because they weren't done doing it. So here's just, select star from tables. I just wanted a slide with everything. This row format is fixed because if you recall, the merge one table just has one int in it. So an int is 4 bytes. It's never less than 4 bytes. It's never more than 4 bytes. The number 1 is 4 bytes, and the number 5 million is 4 bytes. If actually the number 5 million fits into an int, it does, because it's up to like, it's like 1 billion or something goes to an int.
Yes, yes.
4 bytes.
So I recognize that number actually.
Which number?
The
max data length?
Yeah.
It's a big number.
That's
yeah.
big and unsigned.
Yeah. So, you have a question? No. Okay. We talked about checksum. So index objects. This gets a little tricky. There are 4 tables in the information schema that deal with indexes and keys. Statistics, which has to do with indexes. I have no idea why it's called statistics, except I think that we were talking about process list, the statistics and process list. I think that might be like maybe the default name for things like indexing and things. But it's really a pain when you try to look at the key column usage, because you're like, oh, I want to see keys, and it doesn't actually have everything in it because it's just for key constraints. So one thing that's actually pretty useful here is I have this query here. Oops. And, oh, okay. Oh, great. We went through this. Here we go, index objects. So if I go here and I put that query in, which is select table name, index name, group concat, which by default it does a concatenate of everything. It does a concatenate of a list of items with the comma separated. You can actually change the separation by putting a parameter. So right now we're going to concat the column name, but I could say like with a bang if I wanted that comma, if I wanted that bang separated. I'll just leave a comma separated. So group concat column name from statistics, where table schema equals test. So show me all indexes in the test schema, grouped by the index name. So here's this group concat. So all of the indexes, even if there's a multi-column index, and we're going to order it by index name and the sequence in index. Sequence in index. And the sequence in index is if you have an index on A and B, like the one index on both of them, a compound index. The A is sequence in index is 1 and B is sequence in index 2. So basically what I'm doing is I'm showing the indexes here. So here's the table name states, the index name is primary key, and here's the actual column name. So if we had something that was more than one column, like if I want to alter table test.states, add index on state ID state name, which so now we have a multi-column ID. Now what this will do is it actually gives you a comma-separated list of that, which is pretty useful because if you want to say, instead of saying show create table test.states and saying, okay, what are the indexes? Okay, here are the indexes. It's a lot, the output is in a lot better format, and again, you can use it in other queries. You could use this as like a subquery or something. You get it right here, and you get exactly what you want and nothing more. So that's a pretty useful query. The next thing I want to talk about is we have some other tables for keys. Now, key is actually not exactly the same thing as an index. It is in terms of MySQL usage. People will interchange index and key, and so does the syntax in SQL. In most places, you can use index or key. I could have said add key instead of add index. But if you're talking about relational theory, an index doesn't actually exist. An index is an implementation feature designed to make things faster. And the standard doesn't care about faster or slower. It just cares about theory, right? It's not practice. So you don't care theory doesn't care how slow or fast things go. It just deals with things. So it doesn't actually have the concept of index. It has the concept of a key. And a key is short for a key constraint, which makes it easier to remember all this stuff for me because a constraint, I know what a constraint is. It's a limit, right? So the key constraints are things that limit the data. And these are foreign keys, because a foreign key, if you have a foreign key, you say the limit of you is what's only values that are this. The only values are the values that the foreign key does. And primary and unique keys are also key constraints. They're a limitation. You can only have one of this on the data, therefore it's a limit, because this next piece of data cannot have that value. Same thing with a unique key. So those are the key constraints, and that's actually what's in the table called table constraints. So if we do a select star from table, actually let's not do it, well, yeah, constraints where table schema equals test. Again, constraint catalog there for the standard. Schema is test. And it's the same as the table schema. Don't ask me why. They're always going to be the same. I don't know why it's there. The constraint name is primary, which, if you remember, we saw that in the FRM file when we did strings. We saw primary. That's the name. We can't change it. It's a primary key. The table name is states, and the table type is primary key. Note that it does not tell us which column or columns are in this. It's just the table constraint. So it's basically the name of the table and the name of the constraint and the type of the constraint. So if I actually want to show all of the table constraints in test, where table name, how many am I going to see? How many rows am I going to get when I hit enter? Huh? I should get 2. I should get 3. Who thinks I should get 0? Who thinks I should get 1? Who thinks I should get 2? Who thinks I should get 3? Okay. Who doesn't know what to think? Who's waiting for me to hit enter? There's only one. Because there's only one key constraint. This is constraints. Table constraints. There are 3 indexes. But there's only one constraint. The other 2 indexes are not limiting. Right? It's just an index on, there's one index on state name and one index on state ID and state name. Which is really, really important because there's 3 tables relating to constraints and only 1 table relating to indexes. Yes?
So if you add a unique index into the table with the second, would it show as 2?
So if I added a unique index to the states table, would I get 2 rows? Well, let's see. So if I do, you were saying if I do alter table test.states, add unique key, and here's the thing, I could use index or key. I happen to like using key because technically it's a key, not an index, but I'm being pedantic. So add unique key, what do you want? State ID, state name? State name, okay. So now if I do this, I get 2 rows. And you see the constraint name, I can actually change the name here by putting the name on the index itself. But the primary you can't change, or you can't set it anyway. The table schema is test, table name is states, and the constraint type is unique. And you'll see foreign, there's only 3 key constraints.
There's foreign over here.
There are foreign keys too. So you've got some foreign keys. So if I do use information underscore schema, and I do select distinct,
Cities is the table.
well, I'm just going to do select distinct constraint type from table constraints, where table schema, not in, information schema, and MySQL. Because there's actually a table constraint called name or something in the MySQL database. So yeah, we have primary key, unique, and foreign key. No idea why unique doesn't have key at the end of it, but whatever. We don't really need a standard or anything. So, oh wow, we have 5 minutes left. So that's table constraints. We also have key column usage. Column usage.
Sorry, you already did switch it. I'm sorry.
That's all right. Which, again, is only on keys. So it's only on constraints. So this actually will give you the fields. Now there's actually one thing I totally wanted to show, which was, no, not that one. I just want to go, the referential constraints. Because I want to give you guys your homework, and that'll be the last thing I do. So the referential, so this is the key column usage, which just kind of shows you the 3 different types of keys: primary, unique, and foreign. I don't think it's really useful because you can get this kind of stuff like ordinal position in the statistics table, but maybe it'll be more useful in the future. And again, obviously this would be reference table schema, reference table name, reference column name would be better when you have foreign keys. So let's actually go over to yours. This is in the slides. So I'm going to do, we're in information schema, select, concat, so I'm going to concatenate the table name, the string depends on, space, referenced table name, from referential constraints, which has the foreign keys only. That table has foreign keys only, where referenced table name equals address, because ordered by referenced underscore table underscore name. So what this does is it gives you a list. Oh, I don't need the order by because I only have one reference table name. But you can, when I first did the example, I took that out. And so this shows you everything that has a foreign key to the address table. So I don't know about you, but there are plenty of times where I've been sitting there going, what depends on, what has a foreign key to this table? This answers that question. I can actually show you it without the reference table name, so the order by makes a little more sense. And you can see, here's all the things that other things depend on. So obviously, if you want to see everything that that staff depends on, you say show create table staff, and you see all the foreign keys. But this really can answer that question of what does this depend on? So this is now your homework. If you could switch back. Your homework is to create a better MySQL dump. However you do it, write either a wrapper script or a script that echoes MySQL dump commands to make MySQL dump foreign key aware and export tables in the proper order. Because MySQL dump exports them in alphabetical order. So if you have table B that has a foreign key to table C, when you import it, it actually turns off the foreign key checking. Because table B gets imported before table C, but B depends on C. But it's trivial, right, to go through and say, okay, let's take this table, this first table, A. Does anything depend on it? No? Okay, put it in. Okay, let's take the table B. Does anything depend on it? Yes? Okay, was it something that we already came to? No. Okay, then that's okay. Right? But if we get to table B and we say, or what depends on this, and it's something that comes in the future, we're going to wait until later. So shouldn't be hard to do. Who's going to write that up besides Patrick? Alrighty, thank you. Well, I will see you later. You'll give me you'll post it far and wide. But again, it shouldn't be that hard because you have that information. What depends on this table?
There is no order.
So that's your homework.
I just don't get what the point to do it if we can turn off all indexes or whatever and then go down and then turn it on.
So the comment was, I don't see why there's a point to making this MySQL dump where, because you can just turn the indexes off and then turn them on. Yeah.
You wait after every table.
Right. You can, but I don't like to do that. I don't like to turn off the checking. I don't like to turn off the foreign keys. What if somebody turned off foreign keys and then put data into the table, and then I did a MySQL dump of that table? You know what I mean? I don't think that we should ever have to turn off the foreign keys unless we're specifically doing it on purpose.
Yeah, you want to check your data as you're loading it, otherwise you can have all kinds of,
right. And maybe that's why it hasn't been done yet, because nobody sees the point.
Yeah.
However, I see a point, so.
Well, you can have cycles also.
Right. Anyway, I think we're out of time, and so I want to make sure that everyone gets to where they need to go. Thank you guys very much. If you have any more questions or comments,
We'll be glad to stay here.
definitely. Thank you very much. I have some cards. I think Patrick has some cards if you want to come up. So thank you very much. I think there's a little bit more information in the presentation itself. If you want to download the slides, they're on the MySQL Forge wiki. Do you guys want to know how to find that? Who needs to know how to download the slides? Raise your hand. Okay. Who needed to download the slides that's not on Twitter? Okay, I actually tweeted a message a while ago at Sheeri. So probably the easiest way to do it is to go to twitter.com/Sheeri. And slides for Metadata tutorial online, right here, here you go. That's actually the very easiest way to do it. You can also go to the Forge wiki, forge.mysql.com, wiki, Control+, MySQL Conference and Expo, schedules, videos, slides, by day Monday, and then just scroll all the way down to the bottom, understanding how MySQL works, and here you go, slides. All right, go off, have some dinner. I'll see you all week.
Feel free to approach us. Anyone of us, you're allowed to answer questions the entire time you're here.
Yep.